says there's 3 steps to doing an indirect proof, or a proof by contradiction. The first one is figure out what you're trying to prove, and then make the assumption that this conclusion is false by assuming that the opposite is true. Plus it's fun because you're told your whole life not to assume things, but in proof by contradiction, you get to assume things. And then we use logical reasoning, which is the great thing. Instead of having to go step by step, you can use logic or other theorems that we've learned about to prove that this can't be true. So use logical reasoning to show that the assumption leads to a contradiction of the hypothesis, or a contradiction of some other true fact that you know. And then step 3 is you kind of wrap it all up, and you say, point out that since the assumption leads to a contradiction, then the original conclusion, what you were trying to prove, has to be true. Hence it's called proof by contradiction. You prove the contradiction is false, therefore the original thing had to be true. It's not true. The good news is, the first part of your homework, you just get to practice assuming the opposite's true. So, it says, state the assumption that you would make to start an indirect proof for the statement, EF is not a perpendicular bisector. What would you assume is true? EF is a perpendicular bisector. That's the contradiction. So you just assume the opposite is true. Okay, ooh, we're going to say EF is a perpendicular bisector. Well, this just says, because it's a safety assumption. It's like step 1 of the proof. State the assumption you would make to start a proof from trying to prove that 3x equals 4y plus 1. How would you assume the opposite of that? Yeah, do you know the symbol for doesn't equal? I don't know. I think I've always known that.
I really want to know if you backed it up on the first time you did it, or if like.
I think both are okay.
Just do a lot straight down.
Okay, that part's not so bad, right? Ready to actually do one? You notice I only have 2. I just need a little bit of rest, like I said. So it says, write an indirect proof to show that if negative 2x plus 11 is less than 7, then x is greater than 2. Remember when we first started proofs and they were all algebraic like this? They were your favorite types of proofs. Or you would just do step by step to get there, right? But we're going to do an indirect proof, okay? So basically we're given that negative 2x plus 11 is less than 7. We want to prove that x is greater than 2. So step 1, we got to assume the opposite's true, right? What will we assume is true? If we're trying to prove that x is greater than 2, x is less than 2, or x is equal to 2, either one of those would be a contradiction, right? So I think I can. So I would not, if I was writing this, I would write, assume that x is less than 2, or x is equal to 2, or could you say x is less than or equal to 2? Would that be the same? So we want to do the opposite of what, we're trying to prove that x is greater than 2, so we assume the opposite. See what I'm saying? So, an indirect proof, you need to say, like, I always like to say, let's assume. I think that's because that's the way I was taught in college. So I always write the words. Let's assume that x is less than 2. Or you could, that's your first step in your proof. Assume the opposite is true. Now the second step, just like all the proofs we've done, that's the hard step. You got to figure out how to prove that's not true. How can we show that when x is less than 2 or x equals 2 that it doesn't work in the problem? Can we plug in some values that are less than 2 or equal to 2 and see what happens when we get it? Yeah, so in this case, we're not actually going to write out a proof step by step. We're not going to write a paragraph. We're just going to do some math here, and we're going to say, if x equals 2, then 2 times 2 plus 11. Right. You can just kind of write it out. If you solve for it, you're doing a direct proof, not an indirect proof. You see what I'm saying? We're doing this just to kind of baby step us to get to the triangle stuff. And I get 7 is less than 7. You agree with that? Which is not true. 7 is not less than 7, right? So we just proved that it doesn't equal 2, but we also have to exclude when x is less than 2. So how can we prove that it doesn't work when x is less than 2? Pick a number less than 2. That would work, but I'm going to just go with 1. If x equals 1, then negative 2 times 2 times 1 plus 11 plus 7. So I get 9 is less than 7, which is not true. Do you agree with the idea? I'm with you that it would be easier just to solve this. We're trying to get the idea of a proof by contradiction. If I can prove that x is not equal to 2, and if x is not less than 2, what's the only other thing it could be? Then it could be greater than 2. And so that's step 3. Step 3, we can say, since numbers equal to 2 and less than 2 do not work, the only option is that x is greater than 2. Or therefore, x has to be greater than 2. This is the book's way of writing it. Is there much more? Oh my gosh. We plug in 3, it works, right? You get 6 is less than 7. Or 5 is less than 7. And so, notice I wouldn't write all this. I'll write out what I'm going to write in a minute. But in the book says, in both cases, the assumption leads to a contradiction of the given information that negative 2x plus 11 is less than 7. Therefore, x is less than or equal to 2 must be false, so x is greater than 2 must be true. I would write this if this was me. Right now, if I could write all that word, I would say, since values where x is less than or equal to 2 were false, then the only option is that's a proof by contradiction. You assume the opposite's true. Sometimes proof by contradiction is the easiest way to prove something. I agree with you, it's not the easiest way to prove that, because you can just solve it. Well, let's look at a triangle problem. Yes, that one. Oh, wait, just kidding. This is where I've used proof by contradiction when I was in number theory in college. Whenever there's number things, finding something that proves it's false using a contradiction is usually the easiest way to do a proof like this. So it says, write an indirect proof to show that if x is a prime number not equal to 3, then x over 3 is not an integer. There's a whole lot of vocabulary in there. What's a prime number? because what the words I'm looking for. Of any factors other than 1 in itself, right? So it says, write an indirect proof to show that if x is a prime number not equal to 3, then x over 3 is not an integer. What's an integer? Not fractions, not decimals, right? So what's the conclusion here? Right? You have to figure out, we want to find the conclusion and assume the opposite is true. What are we trying to prove here? What's our given? And what are we trying to prove? That's the first thing. X is prime or not. And what are we trying to prove? You could try to just keep picking prime numbers and seeing if they work. But there's an infinite amount of prime numbers, so that's not really a good way to go. Oh, I know, that's my word. No, it's just fun. Because I do it, and I got it in the exchange. It is free, because if you take classes here that you're already taking for high school and it's full credit, you're getting free college credit. But it's high school separately, right?
Yeah. We're not going to get it.
You're not. I was here yesterday, but you just came too late. And I waited, and I had a meeting, and then I called. But I'll wait for you. She told me that. Okay, so what are we going to assume? Which one do we assume the opposite of? We assume the opposite of what the given, or we assume the opposite of what we're trying to prove? It's always assume the opposite of what we're trying to prove. So we're going to assume the opposite of this, right? So we're going to say x over 3 is an integer. One option here is you could just keep picking numbers, values for x that like using non-integers. I'm going to go an abstract way. I'm trying to think of a way to do this just to check. What if I write the same thing? If x over 3 is an integer, then could I say that x over 3 equals some n, where n is an integer? Would that be the same? Equals n, where n is an integer? This is a hard proof. The triangle ones aren't as bad. If I multiply 3 over, would I get x equals 3n? Can x be a prime number if I get x equals 3 times some integer? So I'm doing it very abstractly. I think you could just pick values for x and make it untrue as well. But I think that I could say here, I could stop here, that if x equals 3n, where n is an integer, then x is not my prime number. So couldn't I pick, like, if n was 2, that makes 6, n was 3, that makes 9, like, you could pick any integer for n. Therefore, this is a contradiction. Pretty much you could say that at the end of every proof. This is a contradiction. So, x over 3 is not an integer. So you can say, this is a contradiction, so what I was originally trying to prove has to be true. Let's look at the triangle one, because I promised that it's going to be better. Yes. Someday, if you go to college, you can do that stuff. You can just go or we'll do the next one. This is more our cup of tea. Given triangle JKL has these side lengths, as shown, prove that angle K is less than angle L. Step 1. If I'm going to do a proof by contradiction, what is my first step I'm going to say? Let's assume that the measure of angle K is greater than or equal to the measure of angle L. So wouldn't I have to check both? What did we learn yesterday about sides and angles? So if we assume that angle K is greater than or equal to angle L, what do we know that would have to be true about the sides? So if they were equal, the side lengths would be equal. Yes, that's not true. If K is greater than L, doesn't this side have to be bigger than this side? Which is also not true. So if we can prove that those are not true, then therefore the other one has to be true. Does that kind of make sense at all what I'm saying? The hard part is just kind of summarizing all that, writing all that out. It's why we're two-column proof there, because it's easier to write in two-column proofs. You know, some proofs in math are like pages long. Pages long. That's crazy, right? So, this is what I'm going to write. I'm going to say, if the measure of angle K were equal to the measure of angle L, then JK would have to equal JL. Is that true? But, or you could say, but 7 does not equal 8, right? You could actually use the numbers in a thing to show that. If the measure of angle K were greater than the measure of angle L, then K is JL. JL would be greater than JK, but this is not true. By the given sentence. Step 3. Therefore, since the measure of angle K is greater than the measure of angle, greater than or equal to the measure of angle L, is a contradiction, or is false, feel like I always want to use the word contribution because it's proof by contradiction. Or since it's false, then the measure of angle K is less than the measure of angle.
I was gonna say that, but I was like, I don't want to. It's not.
It's alright. It just happens. Sometimes my brain gets ahead of me. We could play a fun game of seeing if this recognizes what I write. Oh! MLK colon ML. Okay. This is not a new part of your life, indirect proof, but it's something that it's something that is a important type of proof to know about. And it kind of fits well with what we're doing right now, which is why it's kind of thrown into it. The first few on your homework are just stating an assumption, right? So 12 and 15 is you just need to say what's wrong with it. Yeah. So 23 error. We'll go over these tomorrow, and then we'll talk about another inequality in triangles tomorrow, which is just one thing, so we'll be able to talk about it almost all day. Only 2 sections left. The good news for you is 4th hour final is always the very last day. 4th hour final. So you're getting it all next week. I mean, all week. No. Well, I don't know. The new final schedule that it's tentative right now, so hopefully tomorrow I'll have a finalized what I can give you. But right now, the tentative one at 7th hour on the 1st. And then there's no 7th hour. There's no 7th hour. I'm okay with that. I'm okay with that. Keep going.
At least it'll be.
Alright, you have like 10 minutes, so you should start this, so in case you need some help.
Oh. It'll be whatever.
Who else wasn't here last Tuesday?